Term 1, we are going to be starting off with Chapter 3 and just going through the basics of learning to expand. So one of the things we need to be thinking about when we are expanding is focusing on that every term in each bracket must multiply by everything in the other bracket. So let's do this. I've already got the arrows there just to guide us. So we've got 6t take away 8 in one bracket and 2t take away 5. So I'm going to start off with the 6t. So that means we've got 6t times 2t. 6 times 2 is 12. 2 times t is t squared. And then we've got 6t times 5. So 5 times 6 is 30. We've got a negative, so we negative 30. And then put a t there. Then we move to the 8. Just remember with the 8, it's got the negative there. So a negative and a positive with the 2t is a negative. Then I've got 8 times 2 equals 16. And the t. Then I've got negative times a negative is a positive. Negative, and 8 times 5 equals 40. The next step that I'm going to be looking at is I'm just going to be looking at like terms. And I can see right here, I have negative 30t take away 16t. And they are considered a like term. So I will put those together. So I'm just going to rewrite everything. So I've got 12t squared. Negative 30 take away 16 is negative 46. Negative 46t plus 40. Okay, so this time I've got one where I've got surds. So if you can already, please pause the video and have a go yourself. But I'm just going to get straight into it for this one. So we've got in one bracket 5x take away square root 11, and in the other bracket I've got 5x plus square root 11. Now, back in year 10, you would have learnt the difference of two squares rule. And this is what reminds me of a squared minus b squared is equal to oops, a plus b, a minus b. Now, I can straight away see that I know my a here and I know my b. So, and it looks very similar to this bracket part here, whereas a in this case will be 5x and b is going to be square root 11. So I can just apply that straight away. We've got 5x in brackets squared take away square root 11 in brackets squared. I can then simplify that further. I will apply the power of 2 with the 5 and with the x. So 5 squared is 25. So it'll be 25x squared. And a square root and a squared cancels out, so it becomes take away 11. So that means I've got 25x squared minus 11. If you've done it the other way, I would encourage you to check it through the previous method, but also encourage you to look at patterns that you see when we are expanding and also factorizing. This is a similar one. Just be mindful with what I've done here. I've got square root 6, not square root 6x. So sometimes when people write it, they write it where it's got the square root 6x. The whole thing is under the square root part. So this is very similar to before, whereas this one I will do both ways just so we can double check. So I know we are using the difference of two squared rules, which is a plus b and a minus b. So I can then look at, well, A has to be square root 6x and B would be 4. So I'm just going to rewrite it in brackets, square root 6x squared take away 4 squared. I'll then simplify that further. Square root 6 squared, the square roots just cancel out. So it becomes 6x squared, and 4 squared is 16, so take away 16. I can then look at it in terms of the previous one, where every term is timesing by everything in the brackets. So I'll start off with the square root 6x first. Square root 6 times square root 6. It's really saying it's a square, so the square roots cancel, and it just gives me 6x squared. Already starting to look similar. Square root 6x times 4 just gives me 4 square root 6x, and it's positive. Then I look at the next part, the next term, which is negative 4. The negative 4 is timesing by everything inside the second bracket. So negative 4 times square root 6x is the same as what I had before. It's just a negative. So we negative 4 square root 6x, and negative 4 times 4 equals negative 16. Okay, now I've done this part, we can see, let me change color. In this middle part here, one's positive, one's negative, it's the same term, otherwise it cancels out. And that leaves me with 6x squared take away 16, which is identical to what we just had. Okay, now we are moving on. We are going to be looking at a perfect square rule. So in this case here, the same thing is going to be applied. We just need to be thinking, what does the perfect square rule mean? And this is something you would have learnt last year. So we've got a plus b squared is equal to a squared plus 2ab plus b squared. So that is our perfect square root. So now we are just going to apply it. So in this case here, I've got an a is square root 2a squared plus 2 times square root 2a times square root 3b, and then plus b, which is square root 3b, and then I'm squaring it. Okay, so I'll just reuse that rule and just put um, all my numbers in. Now I'm just going to have to simplify this. Let's look at the first one, square root 2a in brackets squared. That will just cancel out the square root. So that means it becomes 2a squared. And then the next part, I've got plus. What are the numbers timesing? Well, I've got 2. What is the square root? Well, square root 2 times square root 3 is square root 6ab. And then the next part is square root 3 squared, just becomes 3, so it'll be 3b squared. Okay, so the next one, we will solve this in 2 ways. So the first way is we're just going to use a rule, and that will be the difference of 2 squares. So the difference of 2 squares, that rule is a plus b, a minus b is equal to a squared take away b squared. I prefer to use this rule purely because there's 3 terms in each and it makes it easier. But we need to also able to see what the rule is. So I'm just going to rewrite our question. and I'm just going to label. So in red will be my A, and I'll pick another color in a minute for my B. So first thing I'm going to do is go A, and I'll pick green, just so it stands there. And my B is B and square root 7. Then I'm on my next one. The same thing is going to occur. I've got my A, but I'm going to see how we got the negative B and the negative square root of 7. I'm just going to take out that negative out the front. So then that gives me B plus square root of 7. So straight away we can see that we've got A is just A, but my B value is B plus square root of 7. So this helps us. So let me, so we don't get confused with colors. I'm just going to change again and make it purple. So if we rewrite this as a squared minus b squared, I've got a squared and I've got my b squared. And my b will be, in brackets, b plus square root 7 squared. So now I've used the difference of two squares. So I've got a squared minus in brackets b plus square root 7 squared. The final step is I could also use the perfect square because the perfect square rule is where I've got one bracket and a square. So let's think about it. We know the perfect square is going to be a plus b squared is equal to a squared plus 2ab plus b squared. If we apply that knowledge, now just remember I'm going to keep my a squared at the front. Okay, so in this case here, this is now a and this is my b. So I will go b squared. I'll put this. I'll put the bracket in so we can ignore that negative for now, just for later. Okay, so b squared, and then I've got plus 2ab. So plus 2 times a, which is b, times b, which is square root 7. And then I've got plus b square root 7. So plus square root 7 squared. I'll simplify that middle part first. A squared, take away brackets, b squared plus 2 times square root 7 is 2 square root 7, and put the b on. And then plus square root 7 squared, just cancels out the square root and makes it plus 7. The last thing that I need to do is just apply that negative inside the bracket. A squared minus b squared minus 2 square root 7b plus 7.